My goal for this channel as of now is to propulsively land a model rocket, and to do so it is an absolute must to have a flight computer on board the rocket, but I will be launching rockets before and after I actually land one, and since I don't want to build a new custom computer for each rocket that I launch, I'm going to make one that fits the needs of all my vehicles. That's why I'm calling my flight computer the All-Rocket Avionics B, or A.R.A.B for short. I'll also be updating the A.R.A.B flight computer over time. A.R.A.B V1 will be some breakout boards soldered to a protoboard. A.R.A.B V2 will scrap all the parts from V1 except for some chip changes as they get updated and get better too, and I will solder them to a PCB. Finally, A.R.A.B V3 will be a PCB, but it will have the chips solder pasted to it, much like the A.V.A flight computer from BPS Space. Okay, so what do you need for a flight computer? It needs electricity and a way to regulate it. It needs to sense its angle, acceleration, and its altitude. It needs to control 2 servo motors for the engine mount. It needs to control a roll wheel. It needs to record data for troubleshooting. It needs to fire pyros for an afterburner or parachute. It needs to know if pyros are armed. This is a safety measure. It'll need to have a processor, and it'll absolutely have to beep and light up. We also need some passive components in there, such as capacitors, resistors, and terminal blocks. For power, I'll be using these 11.1 volt LiPo batteries. To regulate it to 5 volts, I will use the 7805 linear 5 volt regulator. To sense its direction and acceleration, I will use something called an IMU, or inertial measurement unit. There are many different IMUs out there to choose from, but I have some requirements. It must be cheap, widely used, and it can't have a Kalman filter. IMUs with Kalman's filters put the angle and acceleration together to find its point in space. It is good for a lot of things, just not rockets. That's why I'm going to be using the GY521 MPU 6050. Alright, now for altitude. I'm going to use a barometer. You could use a LiDAR or a radar, but those don't work well on things that change position a lot. The barometer I'll be using is the BMP280. To record data, I'll use a flash chip and a micro SD card reader. Data will be sent to the flash chip during the flight, and when it lands, it'll send it to a micro SD card. For the flash chip, I'll use the SPI Flash SD card XTSD, and for the SD card holder, I'll use an SD card slot, no numbers or letters involved. The brains of the operation will be the Arduino Nano Every. There isn't much to say about that. The servos will be controlled by a PWM signal, which will be linked up using some header pins. To fire pyros, you'll need to switch a high load. How do you switch a high load? Well, with relays, of course. No, I'm joking. Don't use relays. It's something that shakes a lot. I'll be using N-channel MOSFETs. They stand for metal oxide semiconductor field effect transistor, and it'll use terminal blocks as access ports. The roll wheel is just a DC motor, and the best way to control one of those is with an L293D dual H-bridge IC. This is just a circuit that can switch the direction of the motor. Speed control isn't all that necessary. Alright, that's all for this video, and the next video will be the schematic design. Thank you, and goodbye.